Hello everyone, this is Zahid Bashir. I am a faculty member at Department of Commerce, University of Gujarat and a PhD scholar in Halle College of Commerce. Today is the 12th day for discussing Stata training and we were on estimating the panel data regression analysis. Previously, we have discussed the first condition when we have time series less than 25 years and number of countries or companies or individuals which are also less than 25. So we were using a data set which contains time series less than 25 and number of countries less than 25. So we estimated the pooled OLS, the fixed effect, and the random effect. So today we will explore further about these conditions. So let's we have uh, the data set again. We have high income dot DTA data, which I have already shared with my participants. So let's start the procedure again. So let's have open this one. It will automatically update the procedure. So let's have open the data set again that we have previously used. That is high income dot DTA data. It is basically a data set which contains the FDI and numbers of determinants relating to high income countries. So it contains 19 countries data and approximately 22 years data from 2000 to 2021. This is basically the 22 years data. So according to this data, our first condition for t less than 25 and n less than 25 is fulfilled. So what we are up to, previously we have practiced the basic commands like xtset for declaring the data set to be panel data set for Stata. Then we have estimated the xt-sum command for estimating the summary statistic for panel data. Then we have estimated the correlation analysis using the same command because it is same for pooled analysis, cross-sectional analysis, and uh, the other forms of analysis. And then we discuss the static panel estimations methods. We have estimated the fixed effect model, the random effect model, and then we applied the Haussmann test in order to decide whether our pooled effect is final or fixed effect is final or random effect is final. So let's again consider the same procedure that we have previously done, like xt set, that is ID. Then we have years to declare our panel to be panel data estimations. Let's drop these two things that we have previously estimated. Then we have estimated the xtreg command for fixed effect. First, we need to enter our dependent variable, then we need to enter our independent variable one by one, like this. Then, after putting the last independent variable, we need to put here comma and FE for fixed effect estimation. And then we press enter. Then we need to write here estimate store fix. This is the command which basically store the estimates that we have computed from fixed effect. Then we need to run the same commands with random effect. Let's have the same commands here copied. Now we need to replace FE with RE for random effect. Then we estimate store random. Then we need to write here Haussmann fixed, random, and click enter. If the p-value of Hausman test is less than 5%, it means your fixed effect estimations are confirmed here. The Hausman test has decided that on this model, on this data, your fixed effect estimations are valid. Now, this is the procedure that we have applied previously. Now, what we are going to do today. So after confirming that fixed effect is the final model for our estimations, let test some assumptions. When your fixed effect is final or your random effect is final, the next thing that you need to confirm is the cross-sectional dependence. That is the assumption. If you have finalized, if you finalize that your fixed effect is final or random effect is final, you need to test three more assumptions in order to validate your fixed effect or random effect. So what are these three assumptions? The first one is cross-sectional dependence. The second one is the group-wise heteroscedasticity. This is basically group-wise heteroscedasticity. And the third assumption is testing the serial correlation. These are the three assumptions that we need to test further for validating our estimations using fixed effect or random effect. So as the fixed effect is final, the first thing that we need to test here is the cross-sectional dependence. So what are these steps? The first step is that you need to run the fixed effect command. We need to run here the fixed effect command first. This is our fixed effect command that we need to run here. We have computed the first step. What is the next second step? The second step is to test the Pasran test or Pasran basically procedure. If this command is not already installed in your system, it will give error. It will consider it as a unrecognized command. Then you need to install XTCSD. CSD stand for cross-sectional dependence. So whenever you need to test the cross-sectional dependence, you need to run this command. If it is not recognized by the Stata, then you need to run this one. So first, I need to run this command. XTCST Pasran ABS. It is saying that command is unrecognized. So what we need to do, we need to SSC install XTCSD. This is the command, and it is going to install it. It is checking the system and the installation is complete. Now we need to run this command again because it was not previously installed. So we need to install it. So what is the p value of this procedure? P value is here. This value is greater than 5%. This is the p value in the first line. So it is greater than 5%. You can see here 0.0623, which is greater than 5%. So what is the interpretation? The interpretation is if PR value is less than 5%, it means H naught is rejected. In that case, we will assume that there is a cross-sectional dependence in our data. But in our case, the PR value is greater than 5%. So we can confirm here that there is no cross-sectional dependence in our data. So our first assumption is fulfilled. There is no cross-sectional dependence, or there should be no cross-sectional dependence. If your PR value is less than 5%, then this assumption is violated. So in our case, our assumption is not violated. So what we have concluded that there is no cross-sectional dependence in our sample. Always remember, if this assumption is not fulfilled, then we need to run these commands. We need to run the xtscc, dv, and then ivs. This is the command which basically controls the cross-sectional dependence in your data. Then your fixed effect results would not be considered final results. Then you need to run this procedure. You need to run xt, scc, dv, and ivs. So let's suppose that in our case, let's suppose that there is a cross sectional. Then we need to run this command xtscc, xtscc. Then I need to put here my dvs and ivs in the same, you can say, the positions. If the dv is fdi and the remaining are ivs. So click enter. This command is also not recognized. So what is the procedure? ssc install xtscc. So it is installing this command, and we have the installation is complete. So we have estimated xtcsc. Now what is this? This is called Driscoll carry standard error. This procedure is adopted when you found cross-sectional dependence in your data. In that case, your fixed effect estimations are not validated. It means previously the Hausman test states that fixed effect model is final, but if cross-sectional dependence is found in your data set or in your model, then you cannot finalize your hypothesis on the basis of fixed effect. Rather, you need to test your hypothesis using Driscoll and Carey standard error. So this would be the procedure. This would be the alternative procedure if your fixed effect is found with cross-sectional dependence. But in our case, because the cross-sectional dependence is not there, uh, therefore we cannot consider the Driscoll and Carey procedure. There is another command here. If this command does not give you suitable results, there is another command that is xtdc2. In that case, you need to take the first difference of your dependent variable, and then you need to take the first lag of your dependent variable. Uh, then you need to take your independent variable. This is another procedure, but as our command is estimated using this procedure, so we don't need to run this. Let's check the second procedure, second assumption, that is to check the group-wise heteroscedasticity. The assumption is that there should not be group-wise heteroscedasticity. This is the assumptions. There should be no group-wise heteroscedasticity in your panel. So if this assumption is violated, there are certain procedure we can adopt here. So we need to check the xtreg command again here as a procedure. So let's run the fixed effect command again. This is the fixed effect command. And after doing this, what we need to do as a second step, we need to write here xtest3. It is the command for checking group-wise heteroscedasticity. xtest3. It is unrecognized so what we need to do, ssc install xtest3. So it will install this command. When you use any command for the first time in your Stata program, you need to install it. But after installation, whenever you are going to use that command, you don't need to install it again. So installation is complete. So what we need to do, we need to run this command for checking the group-wise heteroscedasticity. So you can see here, this is a group-wise heteroscedasticity, and the p-value here is less than 5%. It means our assumption is violated because it states that if the probability greater than chi-square value is less than 5%, it means there is a group-wise heteroscedasticity. But if this value is greater than 5%, we can say there is homoscedasticity. But in our case, the value is less than 5%. So we are confirmed that this assumption is violated. Now, because this assumption is violated, what we need to do? If heteroscedasticity is present in your panel data, you may need to estimate your model with the following. What we need to add in our model, we need to run the same fixed effect model, but with the addition of VCE robust. It will control the group wise heteroscedasticity. It means the command will be same that we were using for fixed effect with the addition of VCE robust. So it will control the heteroscedasticity. We are running the same command here. Put it here and add VCE bracket robust like this, bracket close. Now it is a command to control for group wise heteroscedasticity in fixed effect. Now press enter and it will show you the heteroscedasticity free results. It means because our second assumption was not fulfilled, so we have run this command. Now these are heteroscedasticity free results. It is showing that FD is positively and significantly impacting uncertainties, negatively and significantly impacting capital formation is negative but not significant. Sustainable economic growth is positive and highly significant. GDP growth rate is not significant here with negative impact. GDP per capita is also not significant here. Trade openness is weakly significant because p-value is less than 1.96, but the p-value is greater than 5%, but less than 10%. Inflation rate is positive, but not significant. Exchange rate is negative and highly significant, and real growth rate is positive but not significant. But there is still one more assumptions that we need to check, after which we finalize our fixed effect model. If that assumption is also fulfilled, then we can say that our fixed effect estimations are final. So there should not be there should not be a serial correlation in the model. So this is the assumption. We need to check whether there is a serial correlation in our model or not. So what are the steps? You don't need to run any regression. You need to write XT serial, then your DV. This is basically your Y is your DV. And then you need to write your IVs one by one, IV1, IV2, and so on. So this is the command. So you don't need to run the fixed effect first, XT serial, then put your DV here, then put your IVs one by one like this, and press enter. Command XT serial is not recognized. So what we need to do, we need to write SSC install XT serial and enter, and it is going to install SSC install XT serial not found at SSC, search XT serial. So we need to click on this in order to find this command. Sometimes the procedure is quite different for installing a command, but Stata will let you know. Always remember that whenever you need to install some command in your Stata, you always should be connected with internet. So it is showing you how do I test for panel level heteroscedasticity and autocorrelation. Testing for serial correlation in panel. Web resource, click here to return to the previous window. All right, XT serial is installed. So let me check where XT serial test for serial. All right. So let click on the first command here. Yes, this is showing the XT serial. So click here to install it. It is installing the command. Sometimes the procedure takes some time, so you need to wait the procedure to complete so that you can test your assumptions more accurately. So let's complete the procedure. It is taking some time because the internet today is quite slow, so we need to wait it. Sometime it takes some couple of minutes or couple of seconds, so we need to wait for it. Sometimes the command is too much heavy that it would take a lot of time to get it installed. So don't worry about the procedure. It is checking consistency and verifying not already installed. So it will take some time. Meanwhile, we need to see what is this assumption. If your p-value is less than 5%, there is a serial correlation in the data. But if your p-value is greater than 5%, it means there is no serial correlation. So what if your model contains serial correlation? What you can do? If all or any one of the above is significant, then your final model are. You can apply FGLS. FGLS command is applied if your T is greater than N. In our case, if you would see, if you can check, the number of time period are 22, while the number of countries are basically 19. So the first condition is fulfilled. So if your T is greater than N, it means time period greater than number of firms or number of countries, you need to apply XTGLS. And if your T is less than N, it means time period is less than the number of firms, then you need to apply PCSE. These commands are used when you would find the XT serial or serial correlation in your panel model. So let's check whether the procedure is complete. It is still working. It is taking too much time. So let's cancel this procedure because it is taking too much time to complete. So let's suppose our command, our assumption is violated. Let's suppose what it is saying. Connection timeout. All right. So let's go to the previous window again. Maybe this command is available. Yes, this one. This is also another command. Let us check this one. XT serial. Click here to install. Yes, installation complete. Now you can run this command. So what was my command? That was XT serial. Now you can see here the p-value. The p-value is greater than 5%. It is 0.08. So what was our assumption? If the p-value is greater than 5%, then we can say there is no serial correlation. Now, what we have concluded here, we have concluded uh, about three assumptions. We have tested three assumptions. The first one was cross-sectional dependence. our assumption is not violated. There was no cross-sectional dependence. The second assumption was group-wise heteroscedasticity. This assumption was violated, but we have controlled this using robust controlled this using the robust command. And the third one was serial correlation. It was not also confirmed here. It is not violated. So there was no serial correlation in our panel. So what we have concluded here, we have concluded that fixed effect model is valid. There is one thing that we need to understand. There is one assumption which is violated in our case. A group-wise heteroscedasticity was found in our panel, but we have controlled this assumption. But if we see the procedure that I have outlined here, the procedure is if all or any one of the above is significant. It means if any of the assumption is violated in the bracket, if any, if all, or any one of the three assumptions is violated, then you need to run one of these models too, along with your fixed effect or random effect. So as our condition is fulfilled with t is greater than n, we can run the FGLS here along with fixed effect regression. So how to run XTGLS? You need to write here XTGLS, DV and IVs. So write here XTGLS, and then you need to write your DV and IV in the same positions. Click enter, and this is the result of XTGLS, or this is also called the generalized least square model. Now, what it has shown, it has shown you some different results. If you see the fixed effect after robust command, you can see here there are a lot of variables which were significant previously, like uncertainty was negatively impacting, but it was significant. But in FGLS, if you see, uncertainty was negatively impacting, but this is not, uh, uh, you can say this is not significant. While the capital formation was negative and significant using this command, while previously the capital flow was negative but not significant. So you need to justify if your theory basically requires you that your capital formation should be significant one or significantly impacting, then your generalized least square model would be preferred. But if you have the flexibility, or the theory has the flexibility to consider your previous model, like robust Bayes fixed effect model, then you can consider these estimates. So how to report these estimates in a you can say in a publishable format. So if my fixed effect model is final, so how can I create a table in a publishable format? First, I need to run this command again because my fixed effect model is final here. Then I need to run a command. Let me show you. That was outreg command. I have previously mentioned the outreg command. I think that was here in the output table. Let me show you that command that I have previously used. That was the outrec command. I think that command is missing here. You can find the online the procedure of outrec command. Outrec 2 using Stata. You need to understand how you can run this command. This command is basically used to create a publication-based procedure or a published-based table that you need to find out or you need to report in your publication using outrec command for reporting your table. This is the basic command, outrec2. But with panel data or the fixed effect model, you need to run, yes, this one. This is the complete command. When you have run your panel data command, you need to run this command. So let's suppose I am copying the same command here, like this. This command is basically outrec2. This is the basic ingredients of this command. It will create a Word file containing the document. Then it will include the title of your regression analysis, and it will include some further things like if the country fixed effect is there, it will write yes. If country fixed effect is not there, it will not write yes. So you need to run this command here. Now you can see here myrec.doc. You just need to click on this and then you will find a table like this. It has generated your fixed effect results in a publishable format like this. Now, these are the results which you can report in your article, in your thesis, uh, as a part of publication. You can also edit this table because this is editable version. Like you can make them capitalized. You can go to here. You can make them sentence case or you can make them uppercase like this. Now, the first thing you are seeing in this table is basically the beta value or coefficient value here. So what does these stars means? If you go down in the bottom side of this table, you would see here 3 star means p-value less than 1%. 2 star means p-value less than 5%, and 1 star means p-value less than 10%. So 0.1 means 10%, 0.05 means 5%, and 0.01